might ask you if the reaction is endothermic or exothermic after you do the math. I will very likely ask you that. So if your delta H ends up being negative, it's exothermic reaction. If your delta H is positive, it's endothermic. And let me show you some. That's not these examples. This is just what's the heat capacity of something. I will show you those examples. So here's delta H of the reaction equals negative Q. I'm not going to give you the calorimeter constant like you did in the virtual lab where you needed to have also the calorimeter constant. You don't need this version. You only need the simple version of it. This is the other question, but let me finish up this here. Here is a good one to practice. Slide 33, chapter 9. We've got an acid and a base, and it gives you a bunch of numbers, and you need to find the enthalpy of the reaction. Here's another good one. Slide 34. And this one's worked out for you. There's the enthalpy. And you're applying that negative sign, and you're dividing by moles of limiting reagent. We did this as an extra credit, but we did not take a quiz on it. If you understand this question, you're fine. This is exactly how it will be. And this is an exothermic reaction because my answer is negative. And then the other question from this chapter, before we move on to the last chapter, is specific heat of a metal. And that's negative Q metal equals Q water. So you have two Qs and two MCATs, and you got to solve for something missing, usually the specific heat of a metal. And we have this. This is an example question, but if you want to do your own, these two are very good. And the answers are right here. Slide 29, chapter 9. This one is asking you for the specific heat. This one is asking for the mass of the metal. I would expect either one of those on the final. If you can do these two, you're ready. And that's it. Let me see. Let's define this here. So this is negative mass metal times specific heat metal times temperature. I'm going to write this bigger. I'm going to erase everything. So negative Q metal equals Q water. And remember, it doesn't matter what side you put that negative on, as long as you do your algebra correctly and you only have it on one side, your number will be correct. Okay, so let's expand what this stuff means. We've got mass metal times C, which is specific heat metal. And here's the part where everybody messes up, times the final temperature of the system minus the initial temperature of the metal. And make a note to yourself that the initial temperature of the metal is going to be the higher number, and the final temperature is going to be the lower number. And that's going to give you a negative number right here. And that negative is going to make it become a positive. But don't apply that negative until the end. Just remember, a specific heat cannot be negative, and a mass can't be negative. None of these answers should be negative unless, no, none of those answers should be negative. You should never have a negative number as an answer here. minus temperature initial of the water. And in this case, the water is gonna be colder, well, let me say the same thing I said over here. This number is going to be lower, and this number is going to be higher, and that's gonna give you a positive value right there. And I will either ask you to solve for C or M. One of those two, just like these two questions. Okay, last chapter. The one we did last week. We did a Kahoot, and it has exactly what you need. It will not be any different than that. I will show you some practice problems for the last chapter. Oh shit, it's 9:23, you guys. We gotta get out of here. I'm gonna show you one slide. Two slides. Intermolecular forces, there's 3 of them. London dispersion, dipole-dipole, hydrogen bonding. The Kahoot that we did last week is, I'm gonna have 2 of those questions on there. I hope you came last